Hi everyone. In this video, I will explain two PYQs based on Cayley-Hamilton theorem. C1 PYQ. If matrix A is equal to 2, 3, 3, 5, then determinant of A to the power of 2005 minus 3 into A to the power of 2004 plus A to the power of 2003 is equal to dash. This problem was given on January 22nd, 2026 in shift 1. So what is characteristic equation? If capital A is a square matrix, then determinant of A minus lambda I is equal to 0 is called its characteristic equation. What is Cayley-Hamilton theorem? Every matrix satisfies its own characteristic equation. Now see some formulae. If capital A is a matrix of order 2 by 2, determinant of A minus lambda I is equal to 0. That is characteristic equation. By expansion, it can be written as lambda square minus s1 into lambda plus s2 is equal to 0. That is the characteristic equation. So according to Cayley-Hamilton theorem, A satisfies that equation. Substituting lambda is equal to A square minus s1 into A plus s2 into I is equal to 0. There S1 representing A11 plus A22, sum of the elements in the principal diagonal, that is a trace of the matrix. S2 representing determinant of the matrix. Similarly, in the case of third order matrix, B is equal to Bij 3 by 3. Characteristic equation is lambda cube minus s1 into lambda square plus s2 into lambda minus s3 is equal to 0. Substituting lambda is equal to A cube minus s1 into A square plus s2 into A minus s3 into I is equal to null matrix. So here s1 representing A11 plus A22 plus A33, sum of the elements in the principal diagonal, that is a trace of the matrix. S2 is equal to M11 plus M22 plus M33. Capital M11 representing minor of element A11. Similarly, M22 and M33. There S3 representing determinant of A. So you have to remember these formulae, they are very important. Now let us calculate value of the determinant. The given determinant is represented with GE, given expression. So this is equal to determinant of A to the power of 2005 minus 3 into A to the power of 2004 plus A to the power of 2003. So clearly you can see A to the power of 2003 is common. So this is equal to A to the power of 2003 is taken common. It is A to the power of 2005, A to the power of 2003 taken common. So here A square is left over. Next minus 3 into A left over. That last element will become capital I. So after taking common, this is the expression. We know determinant of AB is equal to determinant of A into determinant of B. This can be written as determinant of A to the power of 2003 into determinant of A square minus 3A plus I. Also we know determinant of A power M is equal to determinant of A whole power M. This is a determinant of A whole power 2003 I am writing into determinant of A square minus 3A plus I. So to calculate the value of the given determinant, I needed a determinant of A and determinant of a square minus 3a plus I. First I will calculate determinant of a. A is equal to 2, 3, 3, 5. Determinant of a, AD minus BC. That is very simple. Determinant of a is equal to 5 into 2 is 10. 3 into 3 is 9. 10 minus 9 becomes 1. So I already calculated determinant of a. Now to calculate determinant of a square minus 3a plus I, first of all we have to calculate a square. Later by simplifying we can get the determinant. But instead of adopting that procedure, I am taking Cayley-Hamilton theorem. So characteristic equation I am writing. So characteristic equation is, to write down the characteristic equation, what is the procedure? Just in the given matrix, subtract lambda from elements in the principal diagonal. Take its determinant equate to 0. So its characteristic equation is, this is element in the principal diagonal. So lambda is subtracted, 2 minus lambda. This element is written same. This element also written same. This is element occurring in the principal diagonal. Subtract lambda. This is equal to 0. So this is determinant of a minus lambda I is equal to 0. That is the characteristic equation. So according to AD minus BC formula, I am expanding that. So it is 2 minus lambda multiplied with 5 minus lambda. 3 into 3 becomes 9. Minus lambda into minus lambda becomes plus lambda square. Minus 2 lambda minus 5 lambda minus 7 lambda plus 10 minus 9 plus 1 is equal to 0. That is the characteristic equation. We know every matrix is satisfying its own characteristic equation. Therefore I can say a square minus 7a plus 1 into that, in place of scalar we have to write I there. So a square minus 7a 1 into I, that I wrote I itself, is equal to null matrix. So I want to express a square in terms of a. Therefore a square is equal to 7a minus I. Say this is second equation. Say this is first equation. Now let us consider given expression. Given expression is determinant of a whole power 2003 into determinant of a square minus 3a plus I. So already I calculated determinant of a is 1. 1 to the power of 2003 is 1 only. So in place of a square I am substituting 7a. 7a minus I. This is minus 3a plus I. So minus I plus I will get cancelled. 7a minus 3a becomes 4a. This is determinant of 4a. But capital A is a matrix of order 2 by 2. So determinant of Ka can be written as k square into determinant of A. So this can be written as 4 square into determinant of A. 4 square becomes 16. Determinant of A is 1. So this product is 16. So that is the value of the given determinant. So in which option 16 was given? C. So in option D 16 was given. One more PYQ. Let A is equal to matrix 2A0 1 3 1 0 5 B. If A cube is equal to 4A square minus A minus 21 into I, then the value of 2A plus 3B is equal to dash. This problem was given on April 8, 2024 in shift 1. So this problem also based on Cayley-Hamilton theorem. Now see, so two unknowns A comma B are there, we have to calculate them. Already had given characteristic equation, just you write in the standard form. So given equation I am writing A cube minus 4A square plus A plus 21 into I is equal to null matrix. Just I wrote the given equation. Now compare with the standard form. A cube, comparing with the standard form, A cube minus S1 into A square plus S2 into A minus S3 into identity matrix is equal to null matrix. Just I am comparing with the standard equation. There S1 representing 4, S2 representing 1 and S3 representing minus 21. Now to calculate unknown B, directly I can take S1 is equal to 4. So what is the meaning of S1 is equal to 4? The sum of the elements in the principal diagonal, that is 2 plus 3 plus B, that is 2 plus 3 plus B is equal to 4. So 2 plus 3 is 5, 5 plus B is equal to 4, therefore I can say B is equal to minus 1. Already I got B. Now I have to calculate one more unknown A. To calculate unknown A, we can calculate from S2. But rather than taking S2, it is a little bit lengthy, I am taking S3. To calculate another unknown, I am taking S3 is equal to determinant of A. But S3 representing minus 21. So minus 21 is equal to determinant of the given matrix. 2 is written same, A we have to calculate, that 0 also written same. Second row 1, 3, 1. Third row 0, 5. I already calculated value of unknown B. B is equal to minus 1. Just you expand the determinant along the first row. So this is 2 into this row deleted, this column deleted. 3 into minus 1 minus 3. This is 5 into 1 5. So minus 3 minus 5. It is minus A into this column deleted, this row deleted. AD minus BC becomes minus 1. 0 into something, last element is anyhow 0. Minus 3 minus 5 is minus 8 into 2, that is minus 16. Minus into minus plus A. This is not 0, it is minus 21. This is equal to minus 21. Therefore I can say A becomes minus 5. So I got B is equal to minus 1 and A is equal to minus 5. But actually you have to calculate the value 2A plus 3B. So let us calculate 2A plus 3B. 2A means 2 into minus 5 becomes minus 10. 3B becomes 3 into minus 1 is minus 3. Minus 10 minus 3, that is minus 13. So in which option it was given? C, minus 13. So B option is the correct option. Here I am giving 2 PYQs on the same model with hints. Practice yourself. For more videos, subscribe.